Right, so this screencast is on graphing quadratics, and we've gone one way. We've gone with, okay, here's the equation. Now this is how to graph it. So complete the square, put it in vertex form, and plot the vertex, find the y-intercept. You can do it that way. How about we factorize it, and that way we put down the roots of the equation, the x-intercepts. We also obviously put the y-intercept in. That's pretty easy. The vertex is always found at minus b over 2a. That's that way. How about we go the other way? And here's a graph. It's obviously going to be a parabola, and just going to give you some information on it. It goes through 5, it goes through minus 1. And I'll also tell you it goes through minus 3 here on the y-axis. Now watch the equation of it. Okay, so in this form, and we want to write the equation in the form ax squared. So find the equation of this parabola in the form y equals ax squared plus bx plus c. Okay, so how would we go about that? Well, in this form, we'd write it as, okay, I know that it goes through minus 1 and plus 5 on the, there it's x-intercepts. So it's got to be in this format. Okay, and how do I find out what a is? Well, I can put in this point here, minus 3, couldn't I? So I could say at y equals minus 3, x is equal to 0. So I've got a, I've got 0 plus 1, so that's 1. I've got 0 minus 5, so that's minus 5. So therefore I've got minus 3 equaling minus 5a. So a is equal to 3/5. So my equation is therefore y is equal to 3/5 x plus 1 x minus 5. I don't want it in that form, though. I want it in this form. So I've got to expand all this out. Probably just leave the 3/5 there. Right, this is x squared minus 5x, just moving the microphone a bit closer, x squared minus 5x plus x, so that's minus 4x, minus 5 goes in there, which is equal to 3/5 x squared minus, you can tell I made this question up because it's not a very pleasant one, minus 12/5 x, and this is minus 3. So y is equal to 3/5 x squared minus 12/5 x minus 3. Good, minus 3 is my y-intercept, that's what I thought, and my x-intercepts is given. So if we're given x-intercepts, start here. Start here when you're given x-intercepts. If you're given some different information, let's say we're given, here we go, let's say we're given that let's go the other way this time, so we're going to go around like this, and we're given here that the vertex, the vertex is what, 2, 6 or thereabouts. Better also give this information away. It goes through 4 on the y-axis. Okay, so I don't know why I got a double bracket there, that's a bit strange. I don't have, oh dear, 2, 6. I don't have the axis information, but I do have vertex information. So let's start with my vertex form, x minus h squared plus k. In this case, my h is 2 and my k is 6. Seems fair enough, doesn't it? And all I need to do is find a. Well, I could put this 0.04 in here and I'm bound to get a. 4 equals 4 for y, 0 for x, because x is 0 here. So it's minus 2 squared plus 6. Keep going here. 4 is equal to 4a plus 6. Get there shortly. 4a equals minus 2, doesn't it? And therefore a is equal to minus 1/2. So my equation is y is equal to minus 1/2 x minus 2 squared plus 6, but I can't leave it in that form. Off I go again. I'm going to leave that, square this out, so it's x squared minus 4x plus 4. put a +6 on the end there, and now what's going to happen, I'm going to have minus a half x squared plus 2x plus 2 plus 6. So finally y is equal to minus 1/2 x squared plus 2x plus 8, and that is what we end up with. I'm a bit concerned about, oh, that's a -2 there, so I was a bit concerned about that +8. It's a -2, I made an error. When you put minus a half times 4, you got -2 plus 6, therefore is +4. And that looks a whole lot better. And that's my y-intercept of 4, and there's the full equation. Right, so if I'm given intercepts, I'll start with that factored form. If I'm given vertex, I start with the vertex form. If I'm just given 3 random points, then I will sub those 3 random points in, create some equations in y and x, and solve simultaneously, and the graphical calculator can come into play there as well. But I'll end the screencast there. I think we're good now to go for exercise 2J, which leaves us just 2K applications of quadratics to go before we finish on this section of work. Okay, all the best. I'll see you soon.